Hi guys, today we are going to talk about solving logarithmic equations. So if you take a look at the top of your notes, first off, a little reminder, this is a logarithm and this is the equivalent exponential function. A lot of times when we solve logarithms, this is what we're going to do. We're going to take a log function, we're going to rewrite it as an exponential. We'll talk about that in a little bit. One thing to notice about logarithms and exponentials: the a in an exponential has to be positive. So if this is positive, whenever you take this to a power, this x is always going to be positive as well. Well, that x would be this x right here. So that x always will be positive. Okay, you cannot take the log of a negative. So when we're solving equations, if we get an x value that's negative, we're going to have to check and see if this entire expression will be negative, because if so, then that's an answer we're going to have to discard. All right, we'll talk about that as we go through the problems. All right, so there's kind of two situations you're going to run into. Either we're going to have a log equals, and then there'll be like a number over here that's not a logarithm. And if that's the situation we're in, then we're going to rewrite as an exponential, and then we'll solve it. Or we're going to have a log on the left, like the entire left side is a logarithm, the entire right side is a logarithm, and if that's the case, the only way that these two expressions can be equal to each other, if this log and this log are identical, would be if this m and this n are identical. So if we're in this situation, we can just let these two logs cancel each other out, set the m and the n equal, and then solve this little equation. And you'll see that happen as well. All right, so those are our rules. Let's solve some equations. So very first example, log base 3 of 4x minus 7 equals 2. This is kind of our first situation here where we've got one logarithm. So let's just rewrite this as an exponential. This base to this power. So 3 to the second power equals, and then the 4x minus 7. That's it. That is now an algebra problem to solve. 3 squared is 9. We're going to add 7 to both sides, and then divide by 4. And that's our answer, x equals 4. If we take that 4 and plug it back in here, you're going to get 4 times 4, which is 16. Minus 7, which is 9. That's fine. That's a positive value. We can take the log of that. And matter of fact, log base 3 of 9 is equal to 2. So that works. The next example, again, I've got a log equals a number. So I'm just going to rewrite this as an exponential. So x squared equals 64. I'm going to take the square root of both sides. X equals positive and negative 8. However, take a look here. This base has to be positive as well. Okay? So if you go back up to the top, that's our a right there. That's our base. And since the a is always positive on an exponential, that a always has to be positive in a logarithm. So these two things right here both can't be negative. Okay? So for this problem, we're just going to get rid of the negative answer. So x equals 8. And that's our answer. For example C, I could do that same trick. I could do 5 to the x power equals 125. However, this one there's a shortcut. It's already solved for x. We've already got the x by itself. So just do this. Do this math. Figure out what the log base 5 of 125 is. If you just happen to know that, that's great. If not, you could always use the change of base formula. And you could do the log of 125 divided by the log of 5 and let your calculator do that for you. But either way, you are going to get an answer of 3. And then that one's done. All right, example D. This one, I have a log on the left. I have a log on the right. So these two logs are going to cancel once I've got the problem set up correctly. The only problem is this 2 right here. I need to take the 2 that's out front, reattach it as an exponent, and now I'm all set. These two logs, I can let them cancel each other out, leaving me with 4 equals x squared. And now just solve the algebra problem. Take the square root of both sides. That'll be plus or minus 2 equals x. Again, I'm always worried whenever I see a negative. The original problem was log base 3 of x. So if I let that x equal negative 2, that's not going to work. Okay? Even though when you look at this, you can see, oh, but the x is being squared, so that's, no. If that original problem, if plugging in a negative gives you a negative that you're trying to take a log of, then that's not going to work. So positive 2 equals x, and that's our answer on that one. All right, example E. So take a look at this one. This one looks a little different. I've got a log, I've got another log, but then I have a number over here. So this is actually like this situation, our first situation, where we've got a log equals a number. We do not have logs on both sides. The logs are not going to cancel out. So here's what we're going to have to do on this one. First, we're going to take this left side and we're going to combine these two logarithms into a single logarithm. This is why we practiced this the other day. So you have two logs that are being added, so I can write them as a single log where the two things that I'm taking the log of are being multiplied. X plus 6, x plus 2 equals 1. Okay, that's why we did that the other day. So now I've got a single logarithm equals some number. I can rewrite this as an exponential, which is how you're supposed to solve this when you just have a log on one side. So I can rewrite this as an exponential, so it's going to be 5 to the first power equals this. Now, I'm going to do a couple things here. First off, I'm going to simplify this, and I'm going to move that 5 to the other side. So over here, I'm going to get 5 to the first power. But over here, let me go ahead and FOIL this out and see what it's going to equal. So x times x, x squared. I'm going to get x times 2, which is 2x. I'm also going to get 6 times x, which is 6x. So altogether, I'm going to have an 8x here. And then a 12. Now, I'm just going to solve this quadratic. I need to get everything to the left, everything to one side. So I'm going to subtract 5. That's 5 to the first. That's just a 5. So I'm going to subtract 5 from both sides. X squared plus 8x plus 7 equals 0. I'm going to now refactor this, because if you've got a quadratic set equal to 0, you want to factor it. So x, factors of 7 that add up to 8 would be 7 and 1. So x equals negative 7 would make that one equal 0, and negative 1 would make that one equal 0. All right, so there's our answers, negative 7 and negative 1. But if you go back and look at the original problems, if I put a negative 7 right here, I'm going to get negative 7 plus 6, which is negative 1. I cannot take the log of a negative. If I put the negative 1 in, what's going to happen? If I put a negative 1 here, I'm going to get negative 1 plus 6, which is positive 5. That's okay. If I put the negative 1 over here, I'm going to get negative 1 plus 2. That's positive 1. That's okay. So the negative 1 actually works. That's our answer. The negative 7 does not. If you look at this, I've got the log of x plus 6. This has a domain restriction. Since this can't be negative, this x plus 6 has to be greater than 0. That means this says that x would have to be greater than negative 6. This one over here, x has to be greater than negative 2. So if you take a look at both of these, this one works. Okay, negative 7 is not greater than negative 6 or negative 2. It's less than. But negative 1 fits both of these criteria. All you really have to do is fit this one. As long as you give me a number that's bigger than negative 6, it's going to work. correction, as long as you give me a number bigger than -2. So this is the more strict. So we talked about that long time ago when we were talking about domains. This is the one that's actually more strict. This one says you just have to be bigger than -6. That one says you have to be bigger than -2, which is actually bigger. Okay, so that's the one you would have to follow. But again, one easy way to do it is just take your two numbers, plug them in, see what works and what doesn't work. Okay? All right. Example F. Now, I've got a natural log minus a natural log equals a natural log. So everything has a log. So we're going to be able to follow the method that says the logs are going to be able to cancel each other out. But not now. This is where everyone makes a mistake. They just want to cancel these logs and go from there. You need to take these two logs that are on the left side and rewrite them as a single log. That's the trick, and that's where people mess up all the time. So I've got a natural log minus a natural log. I can write this as a single natural log. Since these are being subtracted, I'm going to have x plus 2 over x. So two logs being subtracted can be rewritten as a single logarithm with division. Equals, the other side's going to stay the same. Now the logs will cancel. That natural log and that natural log will cancel. And I have x plus 2 over x equals x plus 2. I have a fraction. I don't like fractions. I'm going to cross multiply. X plus 2 equals x times x is x squared. Also x times 2 is 2x. I have a quadratic. I'm going to move everything to one side. So 0 equals x squared. I have a 2x here. I'm going to subtract x. So that's going to be plus just 1x. I'm going to bring the plus 2 to the other side. That's going to be minus 2. So 0 equals my two sets of parentheses. I'm going to have x and x. Factors of -2 that add up to positive 1. That's going to be a plus 2 and a minus 1, which means x equals -2 and positive 1. So if you test the -2, if you put the -2 here, you're going to get -2 plus 2, which is 0. X needs to actually be greater than 0, not 0. So that one's not going to work. That one wouldn't work either. So positive 1 does work, though. So there's our answer. All right, last one, G. I have a log, a number, and a log. This is not going to cancel. What I need to do is I need to get the two logs on the same side. Log x, and then I'm going to add this to the other side, plus log of x minus 21 equals 2. I then need to take these two logs and rewrite them as a single logarithm. So log of, these two logs are being added, so the x and the x minus 21 are going to be multiplied. X times x minus 21 equals 2. Now, I have a log on the left, one single log on the left, and I have a number on the right. I can rewrite this as an exponential, and then I'll be able to solve. First off, this is a base 10. I can now rewrite this. This will be 10 to the second power. That's going to be over here, 10 to the second power. I'm going to go ahead and simplify this. X squared minus 21x. Now I have a quadratic. I'm going to move everything to the left. X squared minus 21x minus 100 equals 0. This is going to factor. Factors of negative 100 that add up to negative 21 are going to be minus 25 and plus 4, which means x equals 25 or negative 4. Again, if you check, negative 4 is not going to work. You put negative 4 here or here, and you're going to be taking the log of a negative. So x equals 25. That is our one and only answer.